Today I want to share with you something I figured out a while ago and tested just today. Well, at least tested whether it is sound in theory, but it's good enough for me, I suppose. You probably know something about how mirages form, specifically inferior mirages, like those puddle-like things over hot roads. The usual explanation is that a hot surface creates a layer of warm air, with cool air above it, which then creates a steep temperature gradient that bends light upwards and creates the mirage. That is, in fact, a perfectly good explanation in many cases. Look, I can even reproduce it in my simulator. Here is a view of the Black Swan platforms with just a standard temperature gradient of negative 0.01 degrees Celsius per meter. And here is one where there is a thin layer where temperature falls much faster than that. You can see a clear reflection of the bottom part of the platforms, an inferior mirage. Great. But something had been puzzling me for some time. Mirages can happen over water, like over the sea or the ocean, where the water is quite cool. And they can happen during hot summer days too, when air temperature is high and the sea is much cooler. In fact, they not only can happen, they actually happen often. And yet such situations are nothing like hot roads, so it is rather unlikely that a layer of warm air forms over the water. What causes the mirages in such cases then? There is actually a factor that is often overlooked in the context of refraction. I've been guilty of overlooking it myself, thinking its influence on refraction was negligible. The truth is that while it often is indeed negligible, there are situations where it isn't, and the sea on a hot summer day can be just such a situation. I am talking, of course, about humidity. See, humid air has a slightly lower index of refraction than dry air at the same temperature and pressure. Essentially, it behaves like air that is slightly less dense, like air with a higher temperature, for example. So, if we have a case where we have a lot of water, like the sea, which has a reason to evaporate a lot, like, say, being bombarded with sunlight all day, it can and will create a layer of very humid air under a layer of less humid air, which is just as if there was warmer air under cooler air. Perfect conditions for a mirage. Well, let's test this out in the simulator. Leave the temperature gradient intact, and add some humidity that is rapidly decreasing in a thin layer. Oh look, a mirage. So that seems to solve the mystery. We don't need temperature to be rapidly decreasing with altitude to get a mirage. Sometimes it's enough if it's the humidity that is decreasing. And that is one more reason why observations at low altitudes over water can give wildly varying results. Bear that in mind the next time you feel the urge to declare that your footage taken near the sea proves a flat Earth. The atmosphere is not as negligible as you may think. When I first realized that humidity alone can cause mirages, it was a bit of a revelation for me. Did you already know that, or was it a surprise to you? Let me know in the comments. And this is all that I had for you today. Thanks for watching and see you in the next one.